Hello, and thank you for stopping by Mainstream Engineering's Tech Talk on our corrosion and wear-resistant metal nanocomposite coatings for aircraft tie-downs, part of Navy topic N211-045. We live in a world where every dollar spent on repair, every hour of downtime, and every moment of potential equipment failure represents a critical vulnerability. We cannot be held back by legacy technologies that drain resources and must continue to innovate on all aspects of our operations. Today, we're focusing on a specific and critical challenge faced by the U.S. Navy: aircraft carrier tie-downs. These might seem like a mundane piece of infrastructure, but they are absolutely crucial. These are the anchor points that secure massive aircraft on ship decks. These are the components that bear enormous stress and constant environmental challenges with critical safety implications. Our nanocomposite coatings are a straightforward and proven way to improve tie-down life and reduce costs with no operational or training changes. First, let me introduce you to Mainstream Engineering. We are an applied research and development company who transforms our technologies into commercial products. We manufacture all of our products at our facility located in Rockledge, Florida, located on the Space Coast. We have been successful on numerous efforts and have a commercial quick product line focused on products servicing the residential heating, ventilation, and air conditioning industry, as well as a military product line focused on the development and production of high-quality, rugged environmental control units, as well as a range of mechanical and thermal products. Our staff consists of over 140 employees with a mix of materials, chemical, mechanical, thermal, and electrical engineers, as well as a wide variety of production, sales, and support personnel. We also have subject matter experts in electroplating and nanocomposites who conduct research in our facility of over 120,000 square feet. We are well positioned to complete the nanocomposite coating development effort and manufacture all of the components in our facility. Current aircraft tie-downs are not lasting the full life of an aircraft carrier, requiring maintenance and replacement. Maintenance is time-consuming. It requires frequent inspections, replacement of epoxy top coatings, or in the worst case, complete replacement. Even just replacement of the epoxy top coatings involves needling off the old epoxy coating and replacing it, while complete replacement requires new parts, welding, and recoating. This is a time-consuming and costly process. Therefore, there is a need for improved tie-downs that can last at least 25 years, and ideally the full service life of the carrier. In order for these new tie-downs to be successful, they must maintain the underlying metal weldability and strength, they must be able to meet NDT acceptance, and they cannot change the tie-down dimensions. They need to be a direct drop-in replacement. So why do the current tie-downs fail and require replacement frequently? Well, the current tie-downs are essentially a steel component that have an epoxy coating that protects them from corrosion. As aircraft are connected to the tie-down and the tie-down experiences wear, this epoxy coating can eventually get worn away. While inspections on it are designed to observe this and replace the epoxy coating, frequently this does not occur, and the bare steel becomes exposed. This bare steel represents a high corrosion risk, especially in the high salt environment that these aircraft carriers are exposed to. Once corrosion begins, it cannot be guaranteed that the steel has the same strength as before, leading to it needing to be replaced. Therefore, the technology that needs to be changed is we need to improve the corrosion resistance in order to prevent corrosion from occurring, and we need to reduce the chance that connecting aircraft and the stress and strain from an aircraft tie-downs job will lead to wear that will eventually lead to this corrosion. And that's where Mainstream's nanoparticle reinforced electrodeposit coatings come into place. Our technology lays down a conformal dual-layered metal nanocomposite coating on the aircraft tie-downs. This coating fundamentally reimagines how we protect our metal surfaces. This protective layer can reduce wear by over 99.5% compared to existing technologies. The coating maintains the original dimensions of the tie-down and provides unprecedented protection. Our approach is elegant in its simplicity. The first layer is a dense, corrosion-resistant barrier, just 1 mil thick. Think of it as a microscopic shield against environmental degradation. The second layer is a robust, wear-resistant coating up to 10 mils thick. This is essentially a superhero-level protective skin for our critical naval infrastructure. Combined, these two layers provide drastically improved wear protection and drastically improved corrosion resistance. This technology is currently at a TRL 5, and its development and deployment is the focus of our program. Now, we're not just talking about our laboratory theory. We've already demonstrated the ability to code up to 16 tie downs per day with a proven performance that exceeds all existing standards. Our technology started at a TRL3. We secured our forging partner, we produced tie downs, we coded them, and then we scaled it up to our full 16 tie downs per day. At the scaled rate, we've demonstrated a 99.5% reduction in wear while demonstrating equivalent corrosion resistance. Currently, we're developing our tie-down installation plan, which changes how the tie-downs are replaced and would enable them to be used on an aircraft carrier. As part of this, we're setting up the QC processes and the bath maintenance for our full-scale system. And then finally, we're developing a coding and monitoring and repair and replacement process. This will make sure that all of the parts we make are completely uniform and can all be used and validated. In the future, we're hoping to install our tie downs on our demonstration ship deck and then do full pull tests on an installed tie down, in addition to accelerated in-service corrosion testing to fully validate that our improved nanocomposite coated tie downs can meet the full performance of the existing components. Like I've mentioned, our core technology is our ability to put down a bi-layer wear and corrosion resistant metal nanocomposite coating that can be applied directly to current tie downs. The primary advantage of this is that we have a 99.5% improvement in wear rate over the legacy epoxy. We have a significant improvement in the strength of the material, and we have a significant improvement in the corrosion resistance. This process is a low-cost deposition process. Once it's set up, it has a very low component cost. The coating is fully conformal and can be made thin or thicker depending on the desired properties. We believe that this technology has the potential to increase the life of a tie down up to the 50-year mark. It is significantly lower cost compared to alternative technologies such as changing the materials of the tie down or increasing the size of them. This is directly insertable into the current supply chain, and it has the ability to be used with current repair and replace processes with no additional training of personnel. Like I mentioned, we are currently at a TRL 5 and focusing on conducting demo installations in simulated aircraft tie-down stresses. In the future, we're looking to do full pull tests, a full installation plan, and demonstrate cutting and welding a new tie-down into place on a simulated and an actual aircraft tie-down deck. We believe that this technology has the ability to be directly inserted into the current supply chain. In the future, there are significant alternative applications that we can examine. Other areas that have high wear environments, this same coating can be used on. For example, chrome replacement, a significant focus currently. So we are currently looking for both prime contractors and folks in the Navy in order to help us transition this technology and provide a platform for some of these tie-down demonstrations. We're currently finishing collecting the validation data that would demonstrate all of the key features of the tie-downs with the hope that folks over at NAVSEA or the PEO aircraft carriers will help enable an actual tie-down test on a representative ship hull. And then in the future, we hope to be able to integrate these tie-downs directly into new ship builds and drastically reduce the need for future repair and future replacement of these tie-downs. Thank you for taking the time to listen to our tech talk about our nanocomposite coatings. We look forward to discussing your specific application. These nanocomposite coatings provide a corrosion-resistant, wear-resistant, hardened surface that can be applied to many different types of steel and other metals. It not only can be used on the aircraft tie-downs, but on other components that need improved performance. So please stop by and contact us, Dr. Phil Cox at pcox@mainstream-engr.com or John Klee at jklee@mainstream-engr.com. We would be more than happy to talk to you about your specific needs in your application. Our goal is to convert these aircraft tie-downs that instead of lasting 5 years, they can last over 50. This will drastically reduce maintenance costs, improve operational readiness, and push the boundaries of what's possible. Thank you.